Hello everyone, I am Dr.M.Manickam, Assistant Professor at Department of Physics, Dr. SNS Rajalakshmi College of Arts and Science, Coimbatore. So, in this lecture series, we are continuously talking about encoders, decoders, De Morgan's theorem. Likewise, we are discussing half adder full adder, like that we are discussing. So, in our previous video, we have discussed about encoders and its types. So, the continuation of this is the continuation of previous video. So today we are going to discuss about the types, remaining types of encoders. One is octal to binary encoder, that is 8 to 3 encoder. So the 8 to 3 encoder or octal to binary encoder consists of 8 inputs, y3 starting from y7 to y0, and 3 outputs, a2, a1 and a0. Each input lines corresponds to each octal digit value, and three outputs generate corresponding binary code. So the figure shows the right hand side figure shows the symbol of the octal to binary encoder. So see this, starting from y0 to y7, that is the input. 8:3 encoder is there. The output will be a0, a1 and a2. This is the logical circuit diagram for 8 to 3 encoder, that is octal to binary encoder. That is starting from y0 to y7. Here we are using totally 3 OR gates. We are using 4 input OR gate logic gates we are using. That is from the 3 OR gates we will get 3 outputs, A0, A1 and A2. So this is the construction of logical diagram of for A23 encoder. So in first A3 output, for A3 output we are taking inputs from Y7, Y5, Y3 and Y1. For second one, for A1 we are taking the input from Y7, Y6, Y3 and Y2. For A2 we are taking Y7, Y6, Y5 and Y4. So likewise we are taking inputs for the output. And this is the truth table for A23 encoder. Here starting from Y7 to Y0 we have inputs, and there are 3 outputs, A2, A1, A0. So if the value Y0 value, if the value of Y0 is 1, means remaining outputs, all the outputs will be 0. So if Y1 is 1, remaining is 0, means input. So A2 will be 0, A1 also will be 0 and A0 will be 1. So if Y3 is 1, means A1, A0 is 1, A2 is 0. So likewise this is the truth table for respective logic gate diagrams. So if the y7 value is 1, means we will get the high value, that is a0, a1, a2 value will be 1. All the outputs value will be 1 if y7 value, input value is 1, remaining is 0. Next one, decimal to BCD encoder. Decimal to BCD encoder. The decimal to binary encoder usually consists of 10 input lines and 4 output lines. Each input lines corresponds to each decimal digit, and 4 output correspond to the BCD code. So the encoder accepts the decoded decimal data as input and encodes it into the BCD output, which is available on the output lines. This is the symbolic representation for decimal to BCD encoder. This is the truth table for BCD, decimal to BCD encoder. So here there are inputs y starting from y0 to y9. There are 10 inputs, then 4 outputs is there. The output values A0, A1, A2 and A4. So this is the truth table for the respective decimal to binary encoder. This is the circuit diagram for decimal to BCD encoder. We are using Y0 to Y9. We are inputs we are using, and then 4 outputs A0, A1, A2 and A3. For this construction of this logic circuit, we are using 4 logic gates, that is 4 OR gates we are using. Next one, priority encoder. So a 4 to 2 priority encoder has 4 inputs Y3, Y2, Y1 and Y0 and 2 outputs A0 and A1. Here the input Y3 has the highest priority, whereas the input Y0 has the lowest priority. So in this case, even if more than one input is 1 at the same time, the output will be in the binary code corresponding to the input, which is having higher priority. So this is the priority encoder. So this is the truth table for priority encoder. That is, there are 4 inputs Y0, Y1, Y2 and Y3 and outputs A0, A1 and V. So this is the truth table for priority encoder. This is the logical circuit diagram for priority encoder. Y0, Y1, Y2, Y3 are connected in different logic circuits to get the 3 outputs V, A0 and A1. So here we are totally 3 and OR gates you are using, and one AND gate, one NOT gate we are using to construct the priority encoder circuits. Then applications of encoders. So some of the applications we are given. Encoders are very common electronic circuit used in all digital systems. We are using this encoder. So encoders are used to translate the decimal values to the binary in order to perform binary functions such as addition, subtraction, multiplication, division purpose. We are using these encoders to convert. So other applications like priority encoders may include detecting interrupts in microprocessor applications. These are the some applications of encoders. So thank you for watching this video. Thank you.